So we're going to wrap up this portion of chapter 0 by talking about the graphs of logarithmic functions and also about their domain and their range. And then that will conclude as much as we're going to do in chapter 0 up to this point. And we'll take a break and take a test on that. And then we'll revisit chapter 0 after that, and then we'll get back into some trig, which is also the latter part of chapter 0. But for now, we're going to focus on the logarithm graphs and their domain and range. A logarithm falls under one of those red flags, one of those metal detector type problems where you need to look for something in its domain. It's like the drug dog that sniffs out, oh, yep, I gotta watch out for something here. All right, so remember those red flag things to look for are, does my problem have a denominator? Does my problem have an even root? And the third one is, does my problem have a logarithm? And logarithms always use the symbol greater than 0. So we've got that written right here as an interval notation from 0 to infinity, but we usually use the symbol greater than 0. The range of a logarithm is negative infinity to positive infinity, which I will more commonly write as all real numbers, because it's the same thing. If you go from the lowest possible number to the highest possible number, you've covered all real numbers. But you work with the domain being greater than 0, not equal to, greater than. Again, so remember your fundamental rules. We've got not equal to 0 for denominators. We've got greater than or equal to 0 for any kind of even root. And we have just greater than 0 for a log. The only other thing I want to point out is a combination of these two. We do have it sometimes where you have an even root that's in a denominator. So if you have both an even root and a denominator in the same question, then you're also just going to use greater than 0 and not the equal to part. That has shown up in a couple homework questions, so I wanted to cover that, make sure. So let's practice finding the domain. Here's a logarithm question, and so we automatically use greater than 0. You take what's inside the logarithm, which is x plus 2, and then that identifies your domain. And so our domain will be all numbers that are greater than negative 2. The range is all real numbers. For part B, it is not a logarithm. It is also not a denominator, and it's not an even root. So this domain is automatically all real numbers. Question C. It is a logarithm. So we'll be using greater than 0, and we take what's inside the logarithm, x squared minus 4. We're going to add 4 to both sides. So x squared should be greater than 4. And now we use a plus minus. So x is greater than the plus or minus square root of 2, okay, because we're using a square root to solve, that's always a plus minus. The minus should always be written on the left, the 2 on the right, and the symbols go in the same direction. So that is our domain. For the last one, we have another logarithm, so greater than 0. We want to take only the part that's in the logarithm, so that's only the 2x minus 1. We don't have to take the plus 3 because it's not in the logarithm. I'll add 1 to both sides, and I'll divide by 2, so x is greater than half. And so the domain here would be that x must stay greater than 1/2. So those are some samples of a domain as it relates to logarithm, and the range for all of them would be all real numbers. So now let's talk about how to graph a logarithm. Every logarithm has an asymptote going down the y-axis. So that would be the first thing for you to do for every logarithm, is to start with that asymptote down the x-axis. After that, Every logarithm comes up along that asymptote, hits 1 on the x-axis, and then curves off to infinity. So that is the basic drawing for a logarithm graph. This graph A happens to have a negative in front. That negative is a reflection, and because it's in the front, it's a reflection over the x-axis. And so I'm going to take my graph and I am going to reflect it so that it goes over the x-axis instead. And so the graph would come, oops, this way. And there's my graph reflected over the x-axis. Remember, reflections always come before shifts. So we do a reflection and then we take our shift. This is going to be a shift left 4 units. And so I want to take my asymptote and my graph and I want to shift them 4 units to the left. Okay, so I'm taking off my asymptote and I'm going to move my asymptote 4 units to the left. So that'll be coming down here. And then my graph, oops, will be coming down along that asymptote and then curving down toward negative infinity. So let's talk about the domain and the range of this graph. The domain, we're going to use the symbol greater than 0, and that would be x plus 4. And so subtract 4, so x must be greater than negative 4, and we can tell that from our graph. There's an asymptote at negative 4, and everything's to the right of that, so this is greater than, so that's our domain. And our range is negative infinity to positive infinity, which another way you can write that is all real numbers. So I'll accept either of those. You can either write it as the inequality with y between negative infinity and positive infinity, or as all real numbers. All right, so let's move on to graph B. We start with our asymptote, and then we also have our function graph that's gonna come up along the asymptote, curve through the number 1, and then head off into the sunset sideways. Okay, we're looking at, this is going to have a reflection impact, but it's backwards. So remember, when you switch this graph, when you write it the correct way, it'll be negative x minus 2. Instead of 2 minus x, it will be negative x minus 2. So that tells me that negative is now inside the ln, which means a reflection over the y-axis. So I am going to turn my graph around and reflect it the opposite direction over the y-axis. So it's now going through negative 1 and has been reflected. Then I want to translate this graph, and because of the minus 2, that's going to go to the right. And so I want to move my asymptote, and I want to move the graph itself to the right and up. So let's get ready to move the graph to the right 2, and also move the graph up 1. So my new asymptote would be to the right 2, and my new graph would also be to the right 2, but would be up 1 as well. So that'll be right here. And the graph will come on up, cross through that value. All right, and there's the graph. So let's work on domain. We're going to use greater than 0 for our domain. We take what was inside the original function, so that's 2 minus x. I'm going to subtract 2 from both sides. So negative x is greater than negative 2, and then I'm going to divide by negative 1, which changes the sign. And so my domain is all x's that are less than 2. And we can tell that from the asymptote also. The asymptote's at the number 2, and everything is to the left or less than that. And then, so that's our domain. And then our range is negative infinity to positive infinity, or all real numbers. So we have the same range as before. So quick 10 minutes. That covers what you need to know about domain, range, and graphs for logarithms. And then I'd ask that you would do your homework, please, on graph paper or grid paper in Notability. All right, thanks, and maybe I'll see some of you on Friday. If not, I'll see you next week, and hope you have a good weekend.